Welcome to Docker Overview. My name is Tomasz Borštner. Docker is an Apache licensed open source platform which is much younger than the Linux container support. Generally, it started around 2013, so it is a young project. But it was a very interesting project right from the beginning because it made some things much easier, and on the other side, it used the technologies that were always part of the Linux kernel. The biggest benefit of the Docker was that let developers finally package their application in a much usable way. They were able to package their application with all the dependencies, with all the proper configuration part, with all the libraries that were needed. So good part of the benefits of the Docker is the ease of use and portability. Docker images, which is the base format, they are specific. They are specific to architecture. They are specific generally to the platform. So if you have a Linux Docker image, then of course you need a Linux kernel. But other than that, you are not limited to specific version of the kernel. You are not limited to specific distribution. So technically, machine where you run those images could be Red Hat Enterprise Linux, it could be CentOS, while on the other side your images could be Debian-based, SUSE-based, so you have much more flexibility. Also, the good part about Docker image format is that it is by default immutable. So the image does not change. You are able to test what is inside. You are able to share part of those images. So whenever you make any change to those container images, a new layer is created. And by having that new layer, you are then able to cache that part. So this is one of the important benefits where it is faster to just transfer the new layers of the image and not the entire image. And also by reusing the same image for the multiple instances of the container, you save a lot of disk storage. Also, because they are small, they are quick to deploy, they are quick to transfer. But there is one big change. Compared to the previous models, the idea of the Docker container is that you simply run one process inside. So one process could be web server, it could be database, it could be any application. So you don't need to change your application in order to run as the container. And when you need more than single process, you could have one process which will then create additional processes for you. So Docker container is not a replacement for a typical virtual machine, but it is a great way to package application, to distribute application, because with every image you have a versioning, so you are able to tell whether you have the latest version or not. It's easy to update to a new version, and when you quickly need to roll out new version of the image to, let's say, thousands of hosts, this is much easier and faster with Docker container images than it would be with the virtual machines or any other method. So Docker technology is actually very nice. And the structure of the architecture is actually like that. You have a host. So your first host should be, for example, build host, where you build those images. You start with the text file called Docker file, where you declare how you want to package your application, what is included inside, what changes you made, and all the modifications. So then this is combined with the application, with the binaries, with the configuration files, and the container image is created. That container image is then pushed to the Docker image registry, which is like a specific file server, to quickly distribute the images between the machines. So instead of manually copying the image between different machines, you simply create an image first locally, then you push it to the registry, and finally you pull it from the registry to every machine where you need it. And the good part is, of course, you're able to run multiple images. They could be exactly the same, they could be different, because they have all their dependencies as part of that image. And the Docker engine is the server part of this solution, which enables you to run such applications. So if you look how you then operate such a solution, You have three components. The first one is the Docker client. Docker client is simply issuing a REST API calls to the server. So it is technically HTTP based. And because of that, it can run on the same machine or anywhere on the network. Then you have the Docker engine. Docker engine is the software which understands these API calls. And this one is referencing with the software to run containers. This one is talking to the operating system. And it uses the technologies from the Linux container. So it uses namespaces to separate containers, so the containers do not see each other. You use control groups to limit their resource usage. You use packet filter to, for example, expose your application externally. You can limit access. You can, for example, limit that your application is not able to access the network. So only external users are able to access the application, but the application is not able to talk to outside. And it uses file system layers. So each of those changes in those container images is another layer, but this is then presented towards the application like it is a simple directory with all the files that we need. And the good part is that it's also actually very easy to start running applications. In many cases, we simply use the docker run command, specify the name of the image, and if the image is not locally present, it will simply run. So you use the command docker run and the image. And your Docker client already knows where to get that image. So usually it's Docker Hub, but it could be also any other system. If it is already local, it will start from the local copy. If not, it will be pulled from the remote container registry and simply run it. So you see, with Docker, it's very easy for the developers to distribute their code, because in many cases, they simply ask you, do you have Docker installed or any container software? If the answer is yes, then you simply run the image and it will be pulled automatically from the registry server and start it. So you don't need to go around and install all the dependencies that are needed. You don't need to check whether you have the proper version of the software, the proper version of the kernel, and the proper version of the operating system. Thank you for viewing this topic.